For more interesting videos, subscribe to Tech Simplified TV and hit the bell icon for updates. Hey guys, welcome to the 9th episode of Perl Programming in VLSI. In this episode, we are going to discuss the object-oriented Perl. So far, we have discussed multiple topics and multiple areas of Perl, but this episode is completely different. And in case you have not seen data structures episode, I'll request you before watching these episodes, please at least watch the data structures episodes. And this episode is kind of different because here the concept is totally different. Okay, and without further delay, let's begin. So in today's episode, we are going to talk about package and module in Perl. Next, we'll go through example of the same. And we'll start from the very basic concept of object-oriented programming. In case you already have this knowledge, it's okay. Otherwise, those who don't have the knowledge will have the concept first. Next, when and which cases the object-oriented programming is used. We'll talk about the details or the different parts of object-oriented programming like object, class, blessings, constructor, destructor, methods, inheritance. Next, we'll go through coding example of creation of class and its object in Perl. We also go through the coding example of inheritance and object creation of that inherited class. Okay, and we will close the entire episode with a very easy way of object creation in Perl through Moose.pm. So this Moose.pm do not install by default, and in case you want to install it, I have made a video of how to install the Moose.pm. I'll provide the link in the description, or you can click on the I button. Okay. So this is the kind of menu for today. Let's start the episode. Perl package and module. Now, before saying anything, the package and the module, why we are looking at this? Because without the package and the module, we cannot write any object-oriented Perl programming. Okay, I'm not talking about the Moose.pm. Okay, I am talking about specifically from scratch when you are writing a Perl class. Okay, and creating its object. So for that, this package and module concept is very, very necessary. Not only this case, in other many cases when you are encapsulating your programs or your subroutine, that time you can definitely use a package. Okay, now here I would like to mention one thing, that object-oriented programming always require package and module. But the package and module is not dedicated to the object-oriented Perl programming. It has its own existence and it can be used in any of the cases where it is applicable. Now, let us start talking about few points. We are well aware of the namespace concept. If you are from if you have learned C++ or Java, you might have come across this namespace. Okay, so each namespace has its own objects and table, data structure, etc. Okay, like a hash table and all. In Perl, packages are actually the namespaces here. Okay, the default namespace of any Perl program is main. Okay, now we do not write main word in the Perl program, but it exists. Even we do not explicitly say, but it exists. Package declaration tells the compiler which namespace to fix for our variables. So we can have a namespace, that means we can have a package, and in that package, whatever variables or subroutines and blah blah blah, whatever are there, so those will come under that particular hood. So that hood is nothing but the namespace, and in Perl, package is the namespace. A module is a package defined inside a file whose name is same as the package. So now module is the capsule of the code. Okay, so I'm not talking of the encapsulation. I'm talking about a capsule which you can pop if you are ill, right? So capsule makes actually capsule encapsulates the whole thing. So this uh, module is a file, and it has a .pm extension rather than .pl extension. This contains the package, and it is called the module. All Perl modules are contained in a global @inc array. I have touch based this thing in the first episode. These are special variables and these are special data structures. So @inc will contain all the modules. A module or package can be included in a program using use or require function. So far whatever we have used, right, like strict module we have used, right? So that module when we have used the syntax use strict. Okay, so you know this already. So we are done with this particular slide. Let's move on. A Perl module. A module is just a set of related functions in a library file. That is a bare definition, and Perl package with the same name as the file. Yeah, we have just said that whatever the package we are writing inside the file, that the same name should be given to the file name. Okay, package name and the file name should be the same. I am not talking about the extension, I am talking about the name. Okay, next, the file extension should be pm and not pl. I have mentioned already. Now the module definition starts with package, then some module. So this is some module is whatever you can write the module name. Okay, it could be Mount Everest. Okay, or it could be my own module. Anything whatever you write. Then we, as usual, we are writing use warning for warning purpose and use strict for the purpose, and then we write all the code subroutine etc, and we close the package by a 1 then semicolon. Here the package ends. So this is the ending statement of a package. So you must not forget this 1 then semicolon. Okay, here this is the closing point of the package. So this is the syntax of the package. Okay, rest of the things whatever you have coded in Perl so far, you have seen all the episodes, they can come under the package. Okay, so package is basically creating or kind of compacting a set of codes inside a namespace, and that namespace is coming as the comes from the package. So in Perl we use the package command here to make the namespace, so we both are same, so namespace and the package. Okay, so in this next slide we have come already, usage of custom module in Perl module. Okay, so once you write this Perl modules, okay, pm files, you can reuse. So this is another kind of usage, that is code reuse. Okay, so pm can be reused in multiple areas. Okay, that is the kind of benefit of the Perl module. Where you can keep it? You can keep it in your current working directory. Okay, for any other directory you can specify it in your chsrc. How? Now I am talking about chsrc. Why? Okay, let's see in the next lines. We can say do the set the environment variable, set env, then perl 5 lib, all in caps. Okay, then you give the path where in the which folder you keep the all the pm files. So you have defined or written 10 pm file you can keep in this particular folder, and in your chsrc file you can write this one. Again, if it is not perl 5 version, then you can write set env perl lib and then again specify. So it's better you specify both. Then in your perl program.pl, myprog.pl, what you can do, that you can use the statement use some module. Okay, we are assuming that in previously as we discussed, you have written a module which is called some module.pm, and you have kept in the above mentioned directories which I have just shown in the few lines before. okay, and from there, and you are writing your myprogram.pl anywhere in your disk, and then you can use the module. Since all these environment variable are now set, now the Perl engine will look for the module inside this defined path. Okay, next you can use another way that requires some module, or you can use require some module.pm. Now this is the basic question that is asked in many of the interviews, that what is the difference between use and require. Syntactically this is the difference, that in use you don't have to mention pm, but when you use require, use require, you can either use or not use. Okay, so we are done with this particular slide. Now please keep in mind, this is a very important slide and the information, because even if you write a Perl module, if you do not do these things, you cannot reuse the code. And how many times you have to copy your same module into the each and every new working directory, that will be cumbersome, and you cannot modify the code. If you modify code one place, and you have to copy it back in all another places. So it's better you keep in a particular area and set the environment variables accordingly, and you can reuse the code anywhere you want. This is generic, this is not for object oriented Perl, this is in any cases where you are actually have defined a Perl module. Now in the next case, let us go. We are done with the slide, let's move on. Package and module example. So we have talked so far about the package and the module. Let me give you example, it's better, right? So here both will be codes. Okay, so I have just colored them in a different way. We start, so we assume that this file has a module, this file has a name abc.pm, and inside it which we are writing package abc. Then we are use strict, use warning, and sub hello. In hello, what we are doing, print hello new world, and we are closing it. Next we are writing another subroutine, it's a inline subroutine. So sub add, then we use the return statement, and we add $_0 and $_1. These two are special variables, and these will represent the first and the second argument that is given in the addition subroutine. Now we close the package, or rather we end the package with one semicolon. Okay, so this is done. We have written this package, we have saved it, and we have kept in the directory we have mentioned in our CSHRC file. In that we have kept. Now we go to anywhere in our disk, and we can write any program. So we are writing some myprogram.pl inside. We use strict, and we use warnings, use abc. So now when we put this command use abc, Perl engine will find that particular abc.pm, and we can use the code whichever we have written inside this. What we do here, how we can call the subroutines, we can do in both ways. One is the abc : hello. If we call like this one, the hello will be called. Another one is that inside a print statement we can use. Here we are, what we are doing, print \n, then 1 + 2 is equal to, and then we are calling the function abc, then : add, then we are providing 1 : 2. So this will call the add function, that is we have written in the Perl module, and it will print the result. So this is the way how you define a Perl module, and how you instantiate it and reuse the code anywhere you want, anytime you want. Okay, so this is the way. So I think enough information is given of creation and instantiation of that module. So let's move on to the next slide. So we are done with the particular Perl package, module, etc., syntaxes and the basics. Now we'll enter into the regime of object-oriented programming in Perl. So here, before doing anything, I would like to mention that object-oriented programming is an altogether different concept. What I could do, that I totally skipped all the concepts and directly jumped into the object-oriented Perl programming. But that will be very hasty for the folks who do not know what is object-oriented programming, maybe first time seeing it. So better to touch base the concept. That's why I've included this concept in this episode. This concept. Most object systems have shared the common concepts. Okay, the understanding these concepts will make easier to read an object oriented code. Now, why we are going through this? I'll come to the concepts, but before that we have to touch base what is the importance. That's why. So Perl object oriented, it is completely class based, and class based is fairly common. Okay, this same concept of class based is used in Java, C++, C Sharp, Python, Ruby, and many other languages, which are also object oriented programming languages. So these are the concept. We start now. We will go to the object oriented concept. Now we are talking about concept. What all these things are there? Let me bring my mouse pointer. So there you can see there are 6 circles or semicircles, or sorry, these are elliptic shapes, right? So here there are 6 concepts. The first, what we start with is the class. Then a class can object. Okay, object is actually a encapsulated data, and the class itself is encapsulated data. Abstraction is the level. Okay, abstractions is the level. Polymorphism, that it could be a multiple shape and figure. So an inheritance is that when we go from one class to its subclass. Okay, so all these concepts stay in object oriented programming. So this is a touch base of the concepts, what all are there, and let's move on. We are done with this particular slide. Real life, class and objects. Now this concept of object oriented programming has come from the real life, is inspired from the real life. Okay, and you may say how. Okay, we are seeing it how. So this is a picture of a class. Now this class is a class where students are going. Okay, now is there a connection? Yeah, that's because for the same very reason I have picked this picture to get into the concept. Now in this class you can see there are a lot of students here sitting. Now they belong to say standard 5. The class is standard 5 and they all belong to it. But so what is common? So they all belong to the same standard, and their age, I'm not going to the fractional figure, but in the round figure they will be all in the same age. Okay, now whatever they are learning same thing at the same time. Okay, so this way they have a similarity. So here all students will be the same. Now the class here, this class, entire class or the standard is a class, and all the each of the students are objects. Now they can be different. So here could be male student and female student. Okay, so this is the basic difference by visual, and merit wise they could be also different. Okay, someone has a good score, someone has so not good score and all. Okay, and if we go to extracurricular activities, someone he may be he can play a violin, or she can play a piano. So these are their own basic attributes. So they have their own attributes, and that is how they are different. Okay, now so but whatever say, this is when I say extracurricular activity, this is a kind of property of the class. Okay, so he has, maybe he's playing a violin, but she can play a piano. But if we see the common, that they can have some kind of extracurricular activity that is common. So when we make it generalized, it becomes the class, and when we make it specific to each and everyone, it becomes an object. Okay, and if you stare at the picture, and if you look back in your old class days when you were in standard 5, you can recall how you were different from your friends in the class. So this is the concept of the objects, and objects could be different from each other. And the encapsulation means you know something about your friend, but not everything about your friend. Okay, you do not know that what the friend how many relatives are there, and what the father, where he goes, and how qualified he is. Okay, at that age you may not know these details. So those are encapsulation. So you cannot see those details. Only if you ask your friend, okay, that okay, what is your father's profession? This is a question, and in object this is kind of a method, that's a query. And when you put the query, your friend answered, my father is a lawyer. Now you get an answer, but you have to get the answer from the object by throwing a query. Now these queries are called methods. Okay, so this is a concept of the object oriented programming. So this is has been derived from the actual life. Okay, that's why object oriented programming is much more like the real life. So that's why I have given the concept. I think enough time has been spent on this particular slide, and you can keep wondering about these things when you go through the entire object oriented section. Let's move on to the next slide. When to use object oriented programming? When the design system which is designed is large, and or it is small while designing, and it could become a large. Okay, so similar to that, when you are when pupils start to register in a class, there may be first 10 student, 20, capacity maybe 50, but the seats over time, maybe 1 month or 2 months, the seats become filled up to 35. So and then some later point 5 more student came, and the total strength of a class become 40. So this way the system can be very small, but it can become large. In object oriented programming, when you are designing a class and object, you keep that concept. There could be similar kind of entries, and they can get populated over time, so more seats can be blocked over time. So this is a case where the object oriented programming comes into picture. The data can be put into obvious structure. So obviously they will be same age, they will have some criteria, they will have some extracurricular activity, they will have some certain amount of merit for a class. That's why I'm relating it. There is a prominent inheritance and polymorphism. I'll come to this later, because at this point I don't think there is a good relevant example. I'll come in the later one when I give you the examples. There is a piece of data on which many different operations are applied. So I said that your object is same, but if you ask different question, right, you will get different answers. These are called methods, and methods give you the reply back in data. You may need to perform some general operations based on the data type. So what is the general operation is done every day in the class? Okay, it's your attendance. You remember, okay, we said yes sir or present ma'am or something like that. Okay, so these are general methods that will be applied on each and every one every day. So chances are that you may add a new data types later. So I told that 5 students came later and they joined the class. So similar way, your data structure can add more objects at later point of time. The implementation of individual components of the system is likely to change over time. The system design is already object oriented. Okay, now you are working in a system and it is already have the object oriented programming. Large number of programmers from multi-site will be using the code, so and the module. So this is a kind of good concept, because today any company is in a multi-site operation. So when you have the object oriented concept, right, they don't have to go to bother to see the inside. Instead they can create a data object, or use a query to get the internal data. So that means the object oriented programming is this way more flexible to use. Okay, if it is on the contrary, if it is a procedure oriented, if they have to know the line by line code, or at least the methodology or something like that. But in object oriented programming, you give the list of methods, you give the kind of data structure it can store, and you are done. You can start working on it. Okay, so we are done with the slide. Let's move on. Objects we'll be talking about. An object is a data structure that bundles together the data and subroutine and operate on that data. So you can find the simile like a student, right? He will have a age, he will have a name, he will have a surname, he will have some parents name, okay, mothers and fathers. He will have an address, and he will have some merit which he has obtained from his previous standard, and definitely there will be lot of other things, okay, extracurricular activity maybe. So it is the kind of this all data will be there. Now the objects data is called attributes, and subroutines are called methods, okay. Here in Perl we are talking, so objects data is called attribute. So the extracurricular activity I was talking about is attribute, and subroutine that we are putting a question that what does your father do is a method to know, okay, what is the profession of your father. Now next, the object can be thought as a noun, a person, a web service, a computer, okay. So object can be any, it can be any, you can think of the concept, okay. The object represents a single discrete thing. So as I mentioned, class represent the entire class, and object is a student. So each unit or each instantiation of that class is object. Now, for example, object might represent a file. This is a generic. I have given more examples, right? The attributes for a file might include the path, content, the last modification type. If for a computer, if you think of an object, a file can be object, and it can have multiple attributes like path, content, last modification time, size, and whether it's a file or a directory, like this. Okay. Next, we go to the class. A class defines the behavior of a category of objects. So it's a generic definition of similar objects. A class name is a category, and the class also defines the behavior of objects in the category. Okay, there is a basic subtle difference in real life class and objects and in the programming. So in real life programming, you can see that individual people are joining, right? Having the same criteria, and I brought into the analogy. But in programming, the class has to be defined first, the data structure, everything has to be defined first, and then we populate the class with object instances. uh, Even in school, we have different standards which represent maybe different classes, and we populate the students later on, okay. There is a visual, we see whatever we see, and actual what is happening is very similar, but the part which we do not see is that in a school, standards are defined first, and then pupils start to populate each class. So the classes comes first, it is defined first, and then the objects gets instantiated or populated, whatever you feel apt. A specific object is often referred to as an instance of a class. In Perl, package can be a class, I said earlier, and now the difference between a package and a class is that isn't based on the how the package is used. Now it's a concept. Basically, the object oriented Perl is a concept, and we'll come to know about a function called blessing, which will make a regular package into a object oriented class. Okay, that blessing function we'll be talking about. So how it can be there? Package, then file, then my host name file, then we right arrow, then new is a routine, and it's called a constructor, and this makes a kind of object, okay. So this is basic structure, okay. This is a class declaration, okay, and we are not showing a blessing functions here, we'll come in the explicit example, okay. So the concept is here. This is how a constructor means how you construct an object, okay, because it's a code, you have to construct each object, and for that you need a constructor. This is a constructor, okay. So now blessings, in this slide we'll be talking about blessings, constructor, and methods, okay. So blessing, most Perl objects are hashes, but object can have instance as per Perl data type and scalar array. Turning a plain data structure into object is done by blessing. I was talking about the blessing even last slide or before. So this blessing actually turns a basic data structure into an object. What is the differences? I'll show some functions that makes a difference between a hash and an object. When a hash is turned into an object, it if you do some query, it returns as an object, okay, not as a hash. I'll show. For that, you see up to the end of this episode. We sometimes say that an object has been blazed into a class, okay, so that is why they call the function of making a data structure into a class, and they means the Perl guys called blazing function, okay. So the constructor. Now constructor is a particular thing that creates an object. Now constructor means it construct the object, okay, and we'll show by explicit example how the object is constructed. Now we and it is typically my file is equal to file, then arrow, then new. This is the typical in Perl syntax, okay, creating a constructor. And then methods are nothing but subroutines with which we can query the data, okay, that will operate in go inside and seek the data and come back and give us the data. The object will still remain encapsulated, okay. The object can contain the data, but the method can fetch that data, okay. Now we are done with the three things. Let's move on to the next slide. Attributes and inheritance. Attributes. Each class can define its attributes. When an object instantiated, we assign values to those attributes. For example, when a file has an object path, attributes are sometimes called properties. So this is nothing but the data. Basically, in class we define the skeleton, and in a object we fill the skeleton with flesh and blood. So all the flesh and blood, they are attributes, okay. Inheritance is a kind of that very similar concept, okay. What you have inherited from your father or mother is your inheritance. Similarly, inheritance means that when you create a subclass, right, it can contain it will have the properties that was in the parent class, okay, and it can have its own different attributes and functions also, okay. Like you have something with common with your father or mother, but you still have your kind of difference with them, so that makes you special. So inheritance is that the things that you have inherited, maybe some quality or property or some knowledge or something. uh, so in the similar concept, when subclass is defined from a class, so it can inherit all the data structures and the methods, everything, okay. So we are done with the inheritance here, and here is an example. You can take that file colon mp3 colon mp3 is a subclass of the module or the class file, okay. So this way we can see anything. So all mp3s are file, but all files are not mp3. This is the concept basically, okay. And here the file is called a superclass of mp3. So superclass means superlative power, okay. So generally our father and mother are superlative, right? So that's what we call a superclass, okay. Now package file colon mp3 and use parent file. So this is the kind of syntax. When we use, we can define the subclass. So you have to write the second line definitely, that use parent file, okay. So this is a kind of inheritance command, use parent file, okay. There are other ways, but I think this is a very handy way to define the inheritance. Overriding. So overriding methods and method resolution. So I'll give an example here. So your father uses maybe hand calculated values, the count the prices that for the grocery, and you use Microsoft Excel. So the goal is same, that you are calculating the expenses which have been for the grocery, but the methods you are applying, right, are different. So this is called overriding. This concept is overriding. So the object or the subclass may have methods which may override the original method, but the goal remains same, okay. So next, inheritance allows two classes to share code. Inheritance allows two classes to share code. By default, every method in the parent is also available in the child. So it is copied, but you can obviously have in the child, you can have its own version where it overrides the parent's method. The child can explicitly override a parent's method to provide its own implementation. Okay, that is what I said. So this is overriding. Okay, now here overriding doesn't mean that you go and have a collision with your father. Okay, it's about the method. Okay, so don't go in that direction. So we are done with this particular slide. Let's move on to the next. Creating a class, student.pm. So here we'll be showing the explicit examples. So get ready. Here we start with our Perl path, okay, that where the Perl comes from. Then we define the package student. Next we use strict warnings, and here we define one. It's simple. It's not very complex. We define a subroutine called NL, means it will add a new line. It's just a simple. It is not mandatory here. Okay. So now we'll go to the construction. This is mandatory. We write sub new, and inside that we write my dollar class is equal to dollar underscore zero. So whenever we will be using this constructor, okay, this method is specifically called constructor because it will construct the each object instance, and the first argument is the class's name. Okay, so it will go to the class. Then my object is equal to it is basically a hash. You can see the data structure. The name is the key and the value is dollar underscore one. So the next arguments are coming in this way. Then surname is the second, the next argument, that is dollar underscore two, and the third is the roll number is dollar underscore three. So this way all the arguments came and this get stored in the internal data structure. Now this hash is been made. Now how we can turn this hash into a object with the place functions that we have written in the next line. Place, then syntax is the object, and then the dollar class. Now if you see the three lines, in first line we have defined the class, we got the name class name, okay, from dollar underscore zero, and in the next when we get the all the data and we punch the data into a single data structure, and we now are saying that this is a object of the class. Okay, the blessing functions does that. Now return object. So here I think we have reached the end of the constructor. So this is mandatory. This is mandatory. This syntax is mandatory for creating a constructor. So this, when this code will be used, this is a class we are defining to create an object. In actual practice, this will be used to create each object. So this is a common code. Okay. Now we can have different methods. Now say we can set name. Now it looks ridiculous. We have already saved the name, right? Then why we want to do the set name? Say in real life you may change your name after certain time, which is feasible. So in the we have kept this particular set name. So but in computer programming it could be that you have made a typo and you need to correct the name. So that's why we are setting this name. Okay, and here we say that my obj, then dash, then a right arrow. So you remember this syntaxes from the data structure in Perl, right? If you are not recalling, please go back and see the episodes of data structure in Perl. Okay, so this is it is equal to dollar underscore one. So why we have given, right, the dollar underscore zero always represents a class. We are skipping that. This is a convention. Dollar underscore zero will always contain the class name. Okay, when we are in the object oriented paradigm, and we have to use the dollar underscore one. So that is name, and then one. Okay, and we continue the code here in the second column. Set surname. So surname we have done, we could have done mistake and we want to make it right. So here again we are writing $_1. Now there could be a question, okay, in previous when the constructor you have written that $_2 and you are writing $_1. So these are not same. So here that was a different subroutine and this is a different subroutine. So for each object oriented subroutine, the first argument is the class and the second argument is how you choose to operate it. So the $_2 is not the always need to be the second argument or whatever we have defined. It is subroutine specific. Okay, the subroutine for the object constructor we have the arguments will be different, and for the rest of the subroutines the order will be the same. The first argument is class and the next argument how we want to operate. Okay, so if we had two arguments we have written in a structure how we want to do it. Okay, then set role, we could have done a typo and we want to correct it. Then again here $obj then is role is equal to $_1. So you can see that we have done the methods through which we can rectify the data. Now this is called a encapsulation. So you use methods to communicate to the object's own database. Okay, now next this was kind of we are rectifying the data. Now we want to display the data. So we are writing a display code, display method here. Now my obj is $_0. Okay, as I said, right, that the first argument is always the object. So we have stored into $obj, right. We could have used the directly the $_0. That is not any issue, but here since you are seeing this first time, I have been very much explicit. Okay, so next is that print name is then we give the instruction $obj then arrow then name, so it will get the name. Then surname is $obj then arrow then surname and print the role. Okay, so this is, and at the last now we have created the constructor. Constructor means that this constructor subroutine has created or allocated a memory space, okay, while this programming is ongoing, and once you are out of the scope that memory has to released. So the destruction function is automatic here of, okay, so we are out of the function, Perl code is going out and exiting completely, and that time that memory has to release. And destructor is used, this sub destroy is a specific function, you cannot use in any other purpose. So here we write print destroy has been called from student.pm. Why? If you do not do anything, right, this destruction function will release the memory for all the data structure you have created. This is important because this object oriented programming is meant to consume huge amount of memory, because these classes and objects will contain huge number of data. Okay, so destructor we have also defined here. So we, in this example, we have known the constructor, the destructor, the methods. Okay, we are quite now familiar with the class. Okay, now let me create an object. We are moving to the next slide, creating object. Okay, so this is and the next piece of code, and it's a different file. We start with the Perl path and use student. Here you can see that we are using use student. Okay, now here the question comes, where we should keep the Perl module. Okay, you can keep it in the path I have which I have told in the maybe in the second slide, right? Okay, in the set env the path. Okay, Perl lib. Okay, so you use that reference, use strict as we do, and then I am writing a hash here. Okay, now your question is why we are writing a hash here? Because I just said that in object oriented programming a hash is turned into an object. We'll see how this hash and an object differs in actual Perl. Is there at all anything the blessing function is doing, or it is just making us think that it is doing something? Okay, for that verification I have included this test hash. Okay, so next is that we write student1 is new student, then give naga and surname and the roll number we have given, and in next student we create that new student, then we given the all the attributes, okay, the name, surname and the roll number. And we write here student 1 then display, okay. We are calling the display method that has been defined in the class to print all the data, internal data of student 1. Now for space we are calling student then nl, so we are calling a subroutine directly from the class, okay. Okay, we could have done with the object also, so that is not a issue. And next we write the student 2 then dollar display, okay, and then we do student colon colon nl. So you see in this nl, right, what we have done, we have called the function in two different ways, or the method in a two different ways. Now we have to print what we are printing. It is very important because these results I will show in the next slide. Here you can see that let me bring my pointer here. Reference type std1 is I have used the .ref function. I have discussed earlier in the data structure series what this ref function does. It actually shows the what type of reference. This is a reference data structure. It's not a explicit data structure, it's a reference data structure. So type of this reference will be displayed, okay. And in the next line I am doing the same for student to a reference. And now comes the purpose why I have written this test hash. Now I am also printing, okay, the reference type of this hash. So I'll see in the example whether these objects and hashes are really different or we are getting fooled, okay, by the Perl, okay. So we'll see whether the outcome is different. So let's move on to the next slide. When we run the code, we see that the data is displayed first. Here let me bring my pointer. First the first student's data is displayed, next the second student data is displayed. Now comes the fact. Here the reference type, if you remember, two students reference type is there and it's a student, okay. Reference type is student, okay. And here the third, which is a pure hash, its return type hash return type, or the data structure reference type is hash. So Perl is not fooling us. Perl is actually turned a data structure into a class here by the blaze function, and the return of the reference is not giving a hash here, instead it is giving a student, okay. So Perl is not fooling us. The object oriented programming is actually turning a hash into a class, okay. So and you can see that this destructor has been called 2 times. Why? We have created 2 objects, so when we exit, right, we have to destroy 2 data structure, first data structure and the second data structure. So destroy will be called the number of times equal to the number of objects that we have created in our code, okay. So we are done with this slide. Let's move on. Inheritance. So we will create this inheritance here through an example. So before going, I have written the first parent class is student.pm. Now we can have a separate kind of genre of students who goes for the internship, okay. So those will be a subclass or a subset, okay, we can say subset of the whole group of students who bagged the internship, okay, in a VLSI company. So that's why I have written this intern.pm, okay. Now how we call it, this inherited class, how we are defining it, we write here, let me bring my mouse pointer here, we write package intern, this is the basic definition, and then we write use parent student. So we are inheriting everything from the student, but there will be something different in the class itself, okay. So next we use the regular Perl packages, strict and warnings, and next we have the constructor of the child class. Here we write again the sub, then new, and then class as usual the first argument, and next is that object, then class, then arrow, then super colon colon new, and $1, $2, $3. Okay, so you can see here, let me bring my pointer again. So here we are creating the object, and what we are doing is that we are using, this is a class and then class then arrow. Okay, and we are using super colon colon new. So super means this particular super class, okay, the superlative class from which we are instantiating. So it is calling that particular function colon colon new. Okay, so we are actually reusing the code or inheriting the basic code that has been defined here. We are inheriting the code in this way. Okay, this is a syntax you have to put in your brain, and this is how you will write. Let me bring the next line. This is I have commented. This is a kind of overriding. This is overriding. Here I have not override. If you do this right, you will override the new of parent. Okay, this way, name at the rate then 1 then 2 then 3. Okay, like this. Okay, this is a kind of overriding. Now we write then obj then company is 4. So we have additional attributes here in the parent, that is in student. This company was not there because in internship when you will get a company name, right, in which you have backed the internship, right? So here definitely this fourth argument is coming. Okay, 1 2 3 4. Okay, so for apart from the class name, I am not talking about it. So the attribute, fourth attribute here is the company name. Okay, so these were same as the parent and this is an additional. So this attribute comes as an additional attribute in the subclass. Okay, and now again what we do, whatever we have written in the object structure, data structure, we are using the place functions to turn that physical data structure into a object oriented data structure. So first come the object and then come the class name. So now the package is intern, so the class will be a type of intern. Okay, and we use the return statement to return the object. Why use the return? Because this is a subroutine. Okay, and next we write sub display here, and we here again in this line I am instantiating the superlative or the parent display subroutine here by super colon colon display. Okay, and also I am printing the additional. So here I am here what is the benefit of inheritance is that I do not have to write the code explicitly again for all the thing. I just instantiate here the display function that has been defined in the parent class. It will print 3 attributes, and for the 4th attribute we have to write this additional statement here, and this will create the display. So here again we call the destructor, and we close the in this Perl module. Okay, okay, because this is a package, right? Right, and here one thing is that here the display will actually will display the internal data structure of this and of not of this but of this. Okay, but this will display whatever has been defined here. So this is way that we can reuse the code. Okay, whatever we call inheritance means that we just inherit the code and we just right away use it. Okay, now let's move on to the next slide. Creating an object inherited class. Now we here start with, it's a separate file, so we again start with the hashbang bin perl and this is a path, and then we use intern and use strict. Okay, and here again I am checking whether using the test again as I've done earlier, so whether to check whether Perl is fooling us or really turning the database into actual object or class. Okay, so here now again what we are doing, student 1 new intern, then we write or name, surname, roll number and the company name, and next whatever we are doing is st2 new intern and then name, surname, roll number and the company name, and we hit the display with the same kind of way we have done. So this display is the display that has been defined in the subclass. Okay, we are using, and we call student.nl. So here we can also use in this code area, right? We can also use the uh, subroutine that has been defined in the parent class. Okay, we can also call it is valid. Next, we call the display sub method for the second object, and again we are calling the NL in a different way. Now here we can use two new things, isa and can. Okay, I'll tell how and why these are used. Now we print again here. Let me bring my pointer. There are too much thing in this line. First we print the object name, and then we check its reference type. Okay, and here we check whether it is a student. This means student 1 is a student. Okay, this is a object. We don't know what is a object and what parent class is. Okay, so here we check whether it is a student, means whatever we are treating here is an intern, whether we are checking whether this is the student or not. Okay, so we are checking the parent class inheritance here. Okay, and we are checking that student 1 can display. So I have separated with isa to check the isa status and can to check the can status. Output will be in the next page, so you will have to focus. So here I am using the can statement. Okay, and it is checking whether we can use the method display. Okay, so next we do the same thing for the another object, and third we again print the hash reference type. Okay, so we'll check whether Perl is fooling us or really making a class or a object. Okay, and direct change of the object name field, this is another way. Let me put the code first and then expect. So here what I will do, four things. Okay, let me bring the mouse pointer here. Here I am doing the name, directly storing this name, and in the 4 lines I am directly printing the data. So this is also valid. You can do this. Okay, instead of going through method, since this Perl and this is a data structure, you can do it in this way. Okay, so let me show what comes when you execute this code. This comes the output. Here we can see the first two data structure, first 4 lines of code, first data structure, second 4 lines are from the second data structure, and you can check here it types here it has been turned into a particular class, that is the intern. Okay, it's no more a hash structure has been converted into a intern by the blessing function isa1. Here isa means we are checking whether it is a parent class, it is a student, and return is 1 means yes, and can is code, so it checks the code exists or not. Okay, so and second case it is also true, and third print statement, it is showing that this is a pure hash. So we can see again in this inherited case the data structure have different identity. First have the object oriented identity, and second one is a pure data structure. So here we have printed the 4 lines direct access to the data structure that we can also use here in Perl. So now the beauty in Perl is that okay, this is a object oriented concept. I know you have done all the things, all the methods are here, but you have the privilege that you can directly access the data structure. Okay, here, and destroy have been called twice here, you can see, because we have created 2 objects. The number of objects we create, the number of times the destruction function has been called, destructor have been called. So we're done with this slide. Let's move on to the next. In this page we are discussing the Moose package, which is installation I have demonstrated in the episode. You can click on the I button or you can look into the description. Okay, so how to use a Moose package. Once installed, we write our code and then we write our package name. Student2 here we are writing, and we assume that this file name we are writing as student2.pm, and here we write use Moose. How you will see that how this will become our this Moose.pm makes our life easy in object oriented regime. It has only 3 statements to create the class. Now let me bring my mouse pointer and explain what is what. Name of the object, this is a class and it has name. That's how you can read. It has name. Name is ro, okay, is a str, okay, and default is nothing. This is two single quotes, not a double quote, okay. Surname is ro, is a str, and default is nothing. Roll number is a rw, it is a int, and default is 0. So you also define the data types, and this is read, okay, and you get all these details, right, and we close it. So this is a very easy way you can look into the documentation of Moose for details. I have touch based here. This is in addition to the actual object oriented programming in Perl, because this is a kind of ready to use module for objects and classes, right, and you can create the data structure. Let me show how you now create a object. Here we start our code. Assume this is a different physical file. Use strict warnings, then use student2, okay, and here we write like how student1, then student2, then arrow new, okay, name, then arrow, then surname, then arrow, then roll, then arrow, okay. This is like how we write in a physical hash. So this is where we just write it, and it's saved as a object, okay, by the blessing functions, all whatever defined inside the Moose. We don't have to care about it, okay. This is a very straight way. Just you 3-line code for, or 4-line code for creating a class, and then in one line you create the object, okay. And next in the we create the second object here, okay. I'm using the same data values that I have done in the earlier example, okay. And then we can just use our direct access to the data structure to print the values, okay, in the same way, right. So if you see here, we end up right here. I have used the direct access of the data structure, then student1, then arrow name, student1, then surname, right. These are hash data structure, but actually this is not a pure hash. It has been converted into a object and class by, okay, internally inside Moose. So here I just access the data structure straight away, here also straight away, and I finish it the code, and the output will be like this, okay. The name, the first data structure is printed here, the second data structure is printed here. So I think we are done with the particular Moose package. You can use it. Installation I have shown already, okay. Now thank you very much for listening up to this point, and don't forget to like, share, and subscribe, okay. So for that's all for today, guys, and bye. See you in the next episode.